Okay, let's do a recap of the log transforms. There are at least three main functions that we can get by doing a log transform, either by taking the log of the data and plotting it on Cartesian axes, or by using log axis on the plot. So if we have a plot where it's a log-log plot, both x and y are log axes, and that function plots as a straight line, then the original data are a power function. The slope of this line, using log cycles, where there's one log cycle, that's one log cycle, and so this is about 2.5 log cycles over 1. That slope is equal to the exponent in the power function. So this would be y equals x to about 2.2. So something similar to a parabola if we looked at this as just x, y as a function of x. If we plot this as a SemiLog function where the log axis is along y, then and it forms a straight line, then that function is an exponential function of x. We can determine the slope of this line where we use log cycles along x and log cycles along y as a function of change in x. We can get that slope, and that will allow us to determine what the coefficient multiplying x up in the exponent is. We have to keep in mind, though, that if we plot the data like this, that it's probably going to be a base 10 log axis. And so this factor of 2.3 shows up that we have to use to go from the slope on the plot to the actual coefficient. When we have data that show up as a straight line on SemiLog axis where the log is along x, then this is a logarithmic function. If we calculate the slope of this function, we take the change of y over the change in log cycles of x, and that slope gives us the coefficient that is out in front and that multiplies the logarithmic function. There's another coefficient that multiplies x within the log function, and we get that by determining the place along the x-axis where y equals 0, and that coefficient is 1 over this value. So, two more things to remember. When we determine the parameters will either have units or they will be dimensionless. In either case, just always specify the units, or if they're dimensionless, say they're dimensionless. So you're not done until you determine the function, the values of the parameters, and the units of the parameters. And then finally, you have to check your results by substitution. So you're going to start off with some data, you're fitting a function to it, then go back to the original data, take a value of x, substitute it in to the equation that you've developed, calculate a value of y, and compare that to the value in the data. And make sure that the functions that you've determined adequately predict the value of y's that are in your data set, that correspond to the value of x that you're using in your check.